All right, now recording. So we're just going to finish up the section that I started yesterday. Go back to our little calendar here. So yeah, the rest of the calendar is all going to be messed up, but at least for this week, it's pretty much going to be one section a day, 9-2, 9-3, 9-4. I did a little bit of 9-4 yesterday, so that'll just help me. 9-5, I'm not sure I'm going to finish 9-5 tomorrow because I need to give you time to do the quiz. Okay. The quiz will be based on some of the formats that you had before. Remember that one page that had all those formulas? So you'll just be picking and choosing out of that. Okay, so I might not finish 9-5 Thursday, but it's okay. I can move it back into the following Monday. Okay. I'm still not quite sure about the date of the test, but we're pretty soon going to finish 9-5 and then 10-1, 10-2. So it's very likely I'll finish all of this by next week, but it might be a little bit too much of a push to have the test next Friday, especially since we have a day off next Thursday. All right, so, but I'll let you know once I decide what I'm going to do. I'll let you know soon enough. Okay. All right, so I'm going to continue on with 9-4. There's going to be certain parts of it that's calculator dependent. So if you can get your calculator handy, have it ready, and I may give you an in-class assignment based on your calculator also. Okay. All right, so some things I'll show you right away about the calculator. So we've already done sine, cosine, and tangent. We now have the inverse trig functions. It looks like sine to the -1, cosine to the -1, tangent to the -1 to get those upper register. That's inverse sine, inverse cosine, and inverse tangent. That's actually the main topic of the next section, section 5, which I'm not starting now, but they actually introduced part of it today in 9.4. Okay, so if you can get your calculator handy, that would be great. Okay, so let's get back to where we were. 9.4, it was 1 to 21 odd and 25 to 51 odd. And I did a few problems yesterday to just make it easier for me for today. Okay, so here we go. All right, so we're solving equations of this type. So last time I did one sine, one cosine, and one tangent, but now they give you some much harder stuff. Okay, for some of them, it looks like you got to do some factoring. So let's see when we factor. Okay, so how about I'll do 17 for you? Cosine squared t sine t minus sine t equals 0. Okay, so how do I do that? Okay, so 9.4, page 637. Cosine squared t sine t minus sine t equals 0. All right, determine all solutions of the given equation. Okay, so I see a common factor of sine t, so let me factor out sine t. Then I have cosine squared t minus 1 equals 0. Well, there's a sneaky way to get rid of the cosine squared t, because I know that 1 is equal to sine squared plus cosine squared. Okay, so I'm going to do this trick. Sine t cosine squared t minus 1. Okay. And here's 1. Cosine squared t plus sine squared t. Right? Cosine squared t minus 1. Here's 1. And notice if I do that, the cosine squared cancels out. I have a negative sine squared t times another sine t. So sine t negative sine squared t equals 0. That's negative sine cubed of t. All right, and when does that happen? Well, that happens when sine of t is 0. Right, so sine of t is 0. Y coordinate is 0. So where do I have a y coordinate of 0? Here and here. 0, pi, 2 pi, 3 pi. So it's basically multiples of pi. So t is equal to k pi, where k is an integer. That's what I want for that one. Okay, so again, I factored out the sine of t, cosine squared t minus 1. I notice I can cancel the cosine squared t if I change 1 to cosine squared plus sine squared, because that's the same thing as 1. And then the cosine squares cancel out. I do have a negative sine squared. Multiply it with this, I have negative sine cubed. That's equal to 0 when sine of t is 0. So that's multiples of pi. So that's pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi, and so on. Okay. All right, so that's that one. For 19, I wasn't going to do it. I'll just give you the hint for 19. See where it says cosine squared x? Change it to 1 minus sine squared x, and then go from there. Okay, but I'll let you try to figure out the rest of it. Okay, so I'm just going to write down the hint for 19, but not do it. So 19, change cosine squared x to 1 minus sine squared x. That's one of the identities, right? Since sine squared plus cosine squared equals 1, it means cosine squared x is equal to 1 minus sine squared x. Okay. If I do that, right? Let's see, where am I? 19. Then I'll have an equation that only says sine squared. Okay, so that's my hint for that one. Okay, 21, I'll do it in its entirety because it looks somewhat complicated. Radical 3 sine t minus the square root of 1 plus sine squared of t is equal to 0. All right. So how about I'll move this thing over and then square both sides. Okay. Don't like all the square roots, so move this over. That means it'll become a plus. Radical 3 sine t equals 1 plus sine squared t square root. And now square both sides. Okay, so that means I go like this. Square, square. Okay, so that makes it a lot easier. So square root of 3 squared is just 3 sine squared t, right? So 3, see what I got here. 3 sine squared t equals, this side, when you have a square root squared, just take off the square root, 1 plus sine squared t. All right, I see sine squared t here, sine squared t there, so let's get them on the same side. We'll move this one over. 2 sine squared t is equal to 1. Divide by 2. Sine squared t equals a half. Do the square root property. Square root, plus or minus. So I have plus or minus 1 over radical 2. Square root of 1 is 1, right? Okay. But you might recognize this more as radical 2 over 2. I rationalize the denominator. I get plus or minus radical 2 over 2. That's basically all the angles that have a reference angle of 45 degrees. That's there, 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 and there. But there's one thing I do have to watch out for. Let's see. Right now I have all of these, but in the original, if I move this over, this has to be positive. So I don't want this expression to be negative. Okay, if I move this over, square root, this thing's going to be positive. So I eliminate all the negative values. So the negative values are here and here. So these two are out. So I want these two. Those will give me positive quantities. All right, so that's pi over 4. That's 3 pi over 4. All right, so I'm going to give my answer as pi over 4 plus 2k pi, or this one, 3 pi over 4 plus 2k pi. I should say t equals, where k is an integer. There we go. Just one more time, we actually have to check whenever we do the squaring both sides. Okay, if you might recall in intermediate algebra that happened when you square both sides, sometimes a solution isn't really a solution until you go back and double check it. Then I realized, okay, when I got to this stage right over here, the right side's positive, so this cannot be a positive. This is not allowed to be a negative quantity. That happens in quadrants 3 and 4. Okay, so I only have the first and second quadrant angles, which are pi over 4, and then multiples of 2 pi after that, and 3 pi over 4 plus 2k pi. So that's what I got there. Okay. All right, so that's it for that. And now the next set of problems involve our calculator. Okay, use a calculator to find all solutions in the interval from 0 to 2 pi. Rounding answer to 2 decimal places. Okay, 0 to 2 pi means I'm using radians. So the first thing I'm going to do is make sure I'm in radian mode, not in degree mode. Okay, so in this calculator, which is one of the TI series, I have a TI 85, TI 81, 82, 83, 84, 85, 86. They all should work the same way. So second function mode. Okay, I'm in radians. Okay, so I want to make sure, yeah, I'm in radian mode, so I'm good. So I will exit. And I'm ready to start. If you have just a regular scientific calculator, the one here that says DRG, that's the one that changes the mode. D is for degrees, R is for radians, G is for gradients. I think I mentioned that before, but we don't use gradients. So let me see what mode I'm in. If I turn this on. Okay, I am in radians. See on the top there, it says rad. Okay, so if I hit it again, if I hit the DRG, it says grad, which stands for gradients. We don't want that. Then it scrolls back to degrees and hit it again, back to radians. Okay, so now I'm in radian mode. All right, so 25 cosine of x. Whoops. Something like that. Cosine of x is 0.184. You want the solutions between 0 and 2 pi. All right. That's a positive quantity. What quadrants will the cosine be positive? All students take calculus. Cosine is positive, 1 and 4. 1 there and 1 there. Okay. In other words, it's 0.184 comma something. Same thing here, 0.184 comma something. We don't care about the y coordinate right now. All right, now, we're not taking the cosine of 0.184. I'm asking what angle is there. So when I take the cosine of the angle, I get 0.184. Okay. To do that, you do the inverse cosine function. It'll give you one angle. It won't give you both angles. It'll only give you one angle. Okay. So I want inverse cosine of 0.184. And in directions, it says round to 2 decimal places. All right, so inverse cosine is the second function. So I hit second function cosine, and on my calculator, it pops up with cosine to the -1. Okay, it doesn't mean reciprocal. It's not reciprocal. It's inverse cosine, and 0.184. 0.184. And once again, some of your calculators, it automatically gives you the left paren. Okay, in other words, it might automatically pop up like that. Then you should close it with the right paren. All right. 1.385 to 2 decimal places, that's 1.39. So this angle is 1.39 radians. Okay. What this means is that the cosine of 1.39 is 0.184. Okay, we're going backwards. It's the inverse function. Okay. So one more time, we're not asking for the cosine of 0.184. We're saying cosine of what angle is 0.184. That's what inverse cosine gives you, 1.39. In other words, if I went back and did the cosine of that angle, I'll show you cosine of the angle, which is cosine of the answer. There it is. I get back my 0.184. Right, so that's one angle. That does not give me the second angle, though. So how do I find this angle? Well, you know by symmetry that this angle here is also 1.39. If I go all the way around the circle, that's 2 pi. So the fourth quadrant angle that I want, so let me write down. Fourth quadrant is 2 pi minus 1.39. 2 pi minus 1.39. Okay. The calculator is not going to give you that. You have to figure that out. The calculator only gives you the quote unquote nice angle. In this case, the first quadrant angle, which makes sense. Okay, so I got the 1.39. This angle is going to be 2 pi minus the 1.39, or yeah, I can do that. So I'm going to hit 2 pi. Okay, I do have a pi button. If you don't have a pi button, just do 3.14. 2 pi minus, what was it again? 1.39, 1.39. 4.89. Okay, so my two angles to the nearest hundredth are x equals 1.39 and 4.89, and that's in radians. And there we go. Now, I'll demonstrate that with a regular scientific calculator. You folks will probably have to go backwards on that. So in this one, to do the inverse cosine, I believe you have to hit the 0.184 first, 0.184. And then second function, inverse cosine. And there it is, 1.385, which is the same as a 1.39. And this calculator doesn't give me a pi button. Or I take it back, there is a pi button. You see it over here, it's above this. Okay, but if you didn't, use pi as 3.14. Okay, let me actually do that. So let me clear. Second function, pi, yeah, there we go. 3.14159, blah, 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 that's pi. Okay, but I was gonna say, if you don't have a pi button, just use 3.14. So let me pretend you don't have a pi button. Okay, so that's 3.14 times 2, 6.28. So that's 2 pi. And then I'm going to go 2 pi minus whatever the first one was, 1.39, right? Minus 1.39. And there's 4.89. And of course, I lost all those digits by rounding off to just 3.14, but we get the same result there anyway. Okay. All right, so that's the way it works. Okay, so I'll show you at least one of each type, cosine, inverse sine, and inverse tangent. Also, so 27, sine x equals 1 over radical 5. Okay, once again, that's positive. Okay, so sine, S-I-N-E, is positive in what quadrants? 1 and 2. When I do this calculation, it's only going to give me the first quadrant angle, the nice angle. Then I have to figure out this one. Okay. So x is inverse sine of 1 over radical 5. Okay. It is possible to do that all in one fell swoop. Okay. Again, make sure you're in radian mode. So inverse sine, second function, inverse sine, parentheses, you do need parentheses this time, 1 divided by radical 5, 1 divided by square root button. My square root button is over here, square root 5. Okay. Inverse sine, not sine, inverse sine. It's the backwards function. 0.46, round it off. Which now means the sine of this angle in radians should be that. Okay, so let me do sine of the answer. 0.447. Well, I'm going to guess that's 1 over radical 5. So let me check if that is 1 divided by square root of 5. And there it is, exactly the same, 0.4472, blah, 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 blah. So it worked. Okay. This is like the undo function. How do you undo a sine? Inverse sine. How do you undo a cosine? Inverse cosine. How do you undo tangent? Inverse tangent, and so on. All right, that's only one angle. How do I get the second quadrant angle? So this is 0.46. By symmetry, this is 0.46. So how do I get this angle? Well, if I go all the way here, I know that's pi radians, right? So I take pi and back up 0.46. Okay, so the quadrant 2 angle is pi minus 0.46, or the answer that I just got. Okay, so let me hit pi minus answer. Oops, that's all right. The answer is 0.44 there. Yeah, sorry, I don't want that. So let me just do pi minus 0.46 as a round off, right? I didn't do that right. I hit the wrong button. I'll get there. Pi minus 0.46. 2.68. All right, so my final answer, the angles are 0.46 and 2.68 in radians. These are radians. Of course, we're not as comfortable in radians as degrees, but that's what we got for that one. Okay, 29 is a tangent. I'll do 31 instead because it's a hidden tangent, is what I like to say. Okay, so 31. Sine of t equals 5 cosine t. All right, so what you do here is just divide both sides by cosine t. Tangent of t is 6. And now that's almost exactly like problem 29, which is tangent x equals 6. Oops, that's not supposed to be 6, I think. It's supposed to be 5. Okay. So all students take calculus. Tangent is positive in which quadrants? All students take calculus. Tangent is positive in quadrants 1 and 3. You're only going to get the first quadrant angle. So t is inverse tangent of 5. Okay, and let me show it to you on the regular scientific calculator, because I know some of you just have the regular scientific calculator. So this one you have to go backwards, which is 5 inverse tangent. So I hit 5, second function inverse tangent, which is right over here. 1.37. Then how do I get the third quadrant angle? It's going to be 180 degrees apart, or pi radians. So just add pi to it. So in quadrant 3, I have 1.37 plus pi. So 1.37 plus pi. So take my answer plus second function pi equals 4.51. Okay, so most of these problems, there's going to be 2 such angles. The one the calculator gives me, and then you have to think about the other one. So final answer t is 1.37 and 4.51. Okay. All right. Okay, now the inverse trig functions for secant, cosecant, and cotangent, they're a little bit tougher. Let's see what we can do. For 33, they give you a hint. Secant is the reciprocal of the cosine, so I just reciprocate. So 33. Secant of t equals 2.24. Now, I do not have a button for inverse secant, cosecant, or cotangent because you don't need it. I'll just work with the reciprocal. So I flip this and flip this. Cosine of t is 1 over 2.24. They even give that to you as a hint. And now the rest of the problem is the same. So I work this problem out just like this one. Again, it's positive in quadrants 1 and 4. So I work the rest of the problem out just like before. So t is inverse cosine of 1 over 2.24. All right, so inverse cosine, second function, inverse cosine, parentheses, 1 divided by 2.24, 1 divided by 2.24, close parentheses. 1.11, rounded off, 1.108 means 1.11. And then the fourth quadrant angle, just like the same strategy here. This is 1.11. I go 1.11 down, or 2 pi minus 1.11. So 2 pi minus 1.11. Okay. 2 pi minus 1.11, or you can just say the answer. So I'll just hit the answer button, second function, answer. 5.175 means 5.18. Okay, so my angles that I want, T is equal to 1.11 or 5.18. All right. All right. Then they got a couple of factoring problems for you, 35 and 37. 37 looks much tougher. So let me help you with 37. Okay. So what do we got? 16 sine cubed minus 12 sine squared minus 30 plus 36x sine x minus 27 equals 0. 16 sine cubed minus 12 sine squared plus 36 sine minus 27. Okay, you see factor by grouping. Okay, remember factoring by grouping? I'll take this and this. So greatest common factor here, I can take out a 4 and a sine squared x, right? So 4 sine squared x. Left behind 4 sine x minus 3. And here I can take out a 9, right? 4 sine x minus 3. All right, then you recall factoring by grouping. I can now take out the 4 sine x minus 3. And then I have 4 sine squared x plus 9, looks like. Equals 0. Okay. Which means either this is 0 or this is 0. But I'll just mention this can't equal 0. This is impossible to equal 0. How come? Sine squared, non-negative, 0 or positive. Multiplied by 4, non-negative. Add 9, it's definitely positive. For sure, it's going to be positive. So it can't equal 0. So only this one. 4 sine x minus 3 equals 0. A little bit of algebra. Sine of x is 3/4. Y coordinate is 3/4. Okay. That's quadrants 1 and 2. Again, the sine, S-I-N-E, is positive in quadrants 1 and 2. Calculator is only going to give me quadrant 1. So x is inverse sine of 3/4. Okay, so 3/4. Why don't I just type in 0.75? I know 3/4 is 0.75, right? So 0.75 inverse sine. So second function inverse sine. 0.848 means 0.85. I use this forward calculator, just inverse sine of 3/4. If you want to just stick to 3/4, then you have to put parentheses. 3 divided by 4. And there it is, same thing, 0.848 rounded up to 0.85. Okay, how do I get the second quadrant angle? I know that's 0.85. So in standard position, it would be pi minus 0.85. Okay, so quadrant 2, pi minus 0.85. So if I don't have a pi button, for those of you who don't have a pi button, just hit 3.14 minus, what was it, 0.85, 2.29. Okay, so my angles are 0.85 and 2.29. And there we go. Okay. All right, so I've shown you 2 sine and 2 cosine. Yeah, I'll do another tangent, although it's almost starting to look like I'm doing all the problems, but I'm sure you don't mind. So 35. Tangent squared x plus tangent x minus 12 equals 0. Okay, this is a quadratic equation in tangent of x. It can be factored like this. Tan x. Coefficients are 1 and negative 12. That would be 3 and a 4, right? 3, 4. They're 1 apart. Product is 12. You want to end up with a positive, so positive should go with a bigger number. Okay. Double check. FOIL. Tangent squared x plus 4 tangent x minus 3 tangent x is tangent x minus 12. Okay. So either this one is 0 or this one is 0. Tan x equals 3 or tan x equals negative 4. Okay, so I'm going to have 4 solutions. This gives me 2. This gives me 2. All right, and just like over here, once I get one solution, the other one's going to be 180 degrees apart from it. Okay, this one's going to be a little bit problematic, and I'll show you why. It has to do with how you get the inverse tangent. Okay, so let me do this. X is inverse tangent of 3. So inverse tangent 3. 1.249 means 1.25. Where else could I be? For the tangent, pi radians apart, or 180 degrees. That's just like the other tangent one that I did, which I can't find right now, but I'm sure we did it. Yeah, this one right here. The other one's 180 degrees apart, or pi radians. Okay, so quadrant 3 is pi plus 1.25. So I'll just take that answer and add pi, plus pi, answer plus pi. 4.39. All right, so right now I have these two. This is going to be more problematic because I know what's going to happen for the answer. So x is inverse tangent -4. Because of the way the inverse tangent is defined, and we'll learn more about that in the next section. Okay, I already know this is going to come out to be a negative number, believe it or not. So inverse tangent of -4. Reminder, to get a -4, you hit this button down here, not this one. This is the subtraction button. This is to make a negative. Inverse tangent of -4. -1.325 means -1.33. And for those of you that have this calculator, to get the -4 first, you have to hit 4. And then this button that says plus minus. So that's how you get -4. And then second function, inverse tangent. There's -1.325, -1.33. Okay. So that is an angle that satisfies the equation. Tangent of -1.33 is -4. But in the original directions, it asks for angles between 0 and 2 pi, right there. 0 and 2 pi. So I need the angle over here and the angle over here. Well, to get this, I can just add pi and add another pi, which would be 2 pi total. Okay, so the second quadrant angle is that -1.33 plus pi. Okay, so I add pi to this. So plus second function pi, answer plus pi. 1.815 means 1.82. And then the fourth quadrant angle, I want to land in the same spot, but it says only stuff between 0 and 2 pi. So I'll just add another pi. So add another pi. Okay, I've landed here, right? That's at 1.82. Add another pi, and I got the angles that I want. 4.957 means 4.96. All right, so there we go. So my 4 angles are that one, that one, that one, and that one. So x is 1.25. How about we put them in order, increasing order? 1.25, 1.82, 4.39, and 4.96 are going to be my angles. Okay. Okay, so I think it's a good time to break. What I have left are 39 to 43, they're in degrees. So we're obviously more comfortable in degrees. And then 45 to 51, they have some double or triple angles. So I'll show you how to do some of those. Okay. All right, so we'll take our usual break. If anybody joined late, please put it in the chat so I can get you for attendance. So we'll start again at our usual time of about 12:10-ish, okay? Okay, folks, let's continue where we are. And see, Sandy, I got you for attendance. Anybody else who joined late, put it in the chat so I can get you for attendance. Let's pick up where we were. Let me start sharing the screen again. All right, so 39 to 43, we're back in degrees, so we're more comfortable in degrees, obviously. A couple of those problems. And then 45 to 51, also in degrees, but you have a double or triple angle. Okay, so we'll do these. I'm estimating it should probably take not even half an hour to finish. So I'll be done probably half an hour or less. Okay, so the remaining problems are in degrees. So second function mode, go to degree mode. Okay, so now I'm in degree mode. And then this calculator, DRG. Okay, now I'm in degree DEG. Okay. Same thing, only I'm in degrees. Theta between 0 and 360, round to 1 decimal place. All right. So how about I do 39? Sine of theta is 1/4. Okay, so y coordinate, that's sine, 1/4. I pretend I'm going a quarter of the way up. My calculator is going to give me this one. I have to figure out this one. Inverse sine of 1/4. Well, I know 1/4 is 0.25, so why don't I do it that way? All right, so on this calculator, which has to go backwards, in degrees, it says DEG right up there. So 0.25, 1/4. Second function, inverse sine. 14.5 degrees, which we're more comfortable with. And so it's around to the nearest 10th, so 14.5 degrees. Oops, I got that in green, but anyway. So this is 14.5 degrees. By symmetry, this is 14.5 degrees. So the angle in standard position is 180 minus that. So quadrant 2, 180 degrees minus 14.5. Okay. So 180 minus 14.5. 165.5. So my two angles are 14.5 degrees and 165.5 degrees. All right, and I'm just looking at this. I don't think I like 43. Let's skip 43, where you have to use a quadratic formula. It's too much to use a quadratic formula and inverse function, so skip 43. So 9.4, skip 43. 9.4, skip 43. Put it in my book also. Skip 43. Okay. That means I should show you 41. 9 tangent squared theta minus 16 equals 0. All right, add 16, divide by 9. All right, add 16, divide by 9. Do the square root property. Right. Plus or minus. Tangent of theta is plus or minus 4/3. Well, that means I'm going to get one angle in every quadrant pretty much. So let me do tan theta is 4/3. Theta is inverse tangent of 4/3. So second function, inverse tangent, parentheses, 4 divided by 3. 53.1 degrees. That's the first quadrant angle. The third quadrant angle, I add 180 degrees to that. Right, so for inverse tangent, the second solution is 180 degrees apart. So 180 degrees plus 53.1. And that's going to be what? 223.1. This one's again problematic when you have a negative. I'm going to get a negative angle, but in directions, they want an angle between 0 and 360. So again, I'll just have to add to it. So, all right, I got tangent theta is 4/3. How about tangent theta is negative 4/3, which means theta is inverse tangent of 4/3. Negative 4/3, sorry. So let's try that. So inverse tangent, negative 4/3. You know, exact same thing except the negative, which is actually not that surprising. Negative 53.13. Okay, but I have to translate that to angles between 0 and 360. Okay. So that angle is here somewhere. So I just add 180, I'll get the one over here. I'll add another 180 to get the one over here. Okay, so what do we get? Negative 53.1. Okay, so quadrant 2, negative 53.1 plus 180. So I'll take my answer, add 180, 126.9, round it off. And then the quadrant 4 angle, I add another 180. So plus another 180, 306.9. 126.9 plus 180, 306.9. Right, so I have 1, 2, 3, 4 solutions total. So my thetas are 53.1 degrees. And I'll do it in order. The next biggest one is 126.9. Then the next one would be 223.1. And the last one is 306.9. Okay. Raise it up. Focused. Okay. Then some of the problems at the end, multiple angles. What happens if there's a 3 theta or 2 theta? Okay. So I'll show you how to do one of those. We start off with 45. Cosine of 3 theta equals 1. They said theta is between 0 and 360, right? Let me do a substitution. So how about let O alpha equal 3 theta, which means cosine alpha is equal to 1. That's a lot easier, right? But if theta is between 0 and 360, let me multiply all of these by 3 times 3 times 3 times 3. 3 times 0 is 0. 3 theta, 1080. The reason why I do that is that tells me what alpha does. Alpha is between 0 and 1080. That's 3 revolutions. So I want all the solutions going around once, twice, 3 times. Okay, so I'm solving cosine of alpha equals 1, going around maximum of 3 times. Okay, x coordinate is 1. Well, that's right here. That's 0, 360. Another 360 is 720. And one more time is 1080. So my solutions in alpha are 0, 360, 720, and 1080. But the original problem asked for theta. So I change this back to 3 theta. 3 theta equals 0, 360, 720, and 1080. And then I divide them all by 3, where you do that. So divide by 3, divide by 3, divide them all by 3. And then you have it. So that's 0 degrees, 120 degrees, 240 degrees, 360 degrees. And that's my final answer. Okay, so what I did was I temporarily made a substitution, call it alpha. Okay, if theta is between 0 and 360, multiply it by 3, by 3, by 3. Okay, 3 theta or alpha is between 0 and 1080, which is going around 3 times. Cosine alpha equals 1. X coordinate is 1. That's at the beginning, 0. Also 360, also 720, also 1080, going around a maximum of 3 times. Substitute back, that's 3 theta, divide them all by 3. And these are the angles that I have. Okay. Show you another one like that. Um, 51. Sine 2 theta equals radical 3 cosine 2 theta. Divide by cosine 2 theta. Divide by cosine 2 theta. Cancel. Tangent 2 theta equals radical 3. All right, so once again, I'll make a substitution. Let alpha equals 2 theta. So I'm doing a much easier equation. Tangent of alpha equals radical 3. Let's see where alpha goes. If theta is between 0 and 360, multiplied by 2 this time because alpha is 2 theta. So times 2 times 2 times 2, 0 less than or equal to 2 theta less than or equal to 720. The reason why I do that is because 2 theta is alpha. So alpha is between 0 and 720 degrees. That's 2 revolutions. So twice amount. All right, so how do I do this? We've played this trick before. Make it sine alpha over cosine alpha equals radical 3 over 1. And the trick is to divide top and bottom by 2 because it works. Like that. So sine alpha equals radical 3 over 2. And cosine alpha equals 1/2. But they can both be negative, actually. Right? Remember, tangent's positive in quadrants 1 and 3. So I should really put plus or minus. So I should have put that at the beginning. So I'm going to sneak in a plus or minus. Plus or minus. Okay. X coordinate is plus or minus 1/2. That's there and there. Got an angle there, angle there. Okay, so this is 60 degrees. Add 180 to 40. But we have to go around twice. So add another 180 and add another 180. Okay, so alpha is 60 degrees, 240 degrees. Add another 180, 420. Add another 180, 180 plus that would be 600. Because we're allowed to go between 0 and 720 degrees. Okay, that's alpha, but let me change it back to what it was. Alpha was 2 theta. 2 theta is 60 degrees, 240 degrees, 420 degrees, 600 degrees. And you can guess what happens. Over here, I divide them all by 3. Over here, I divide them all by 2. And there we go. So I have 30 degrees, 120 degrees. Let's see, what's that, 210 degrees? And 300 degrees. There we go. Okay, and I'm finished, folks. So I'm going to do my focus thing, and then we're going to be done. So if anybody has any question, you can put it in the chat now or unmute yourself as soon as I do this. Otherwise, we're finished. I'm not sure if I did this the front page. So it's everything we did today, okay? There's all that. And all this. And this. So yeah, if you ever have a question about anything, put it in the chat now. I'll check the chat shortly. But if not, then we're going to be finished. There's all that. And now all this. Okay. So according to schedule, I'm over here, so 9.4. Tomorrow, 9.5. I'm not sure I'll finish it because I need to give you time to do the quiz. All right. And then for exam 5, all we would have left after 9.5 is just 10.1 and 10.2. That would be test 5. Here's test 6, and then we're done with the course. All right. Okay, so let me check the chats. And I don't see anything else in the chat. So if anybody else has a question, ask it now. Otherwise, we're finished, folks. So anybody with a question, please? All right, so that'll do it for today, folks. So have a good day. Tomorrow, do the section and be ready for the quiz. All right, have a good day, everyone. See you next time.